Imagine discovering that your brain has been quietly protecting you your entire life using a feature you were never taught about. A feature so subtle that for decades scientists mistook it for a flaw, a limitation, even a weakness. What if moments when your mind feels foggy, when perception narrows, when stress seems to shut parts of you down, are not failures at all, but signs of a hidden system activating? The human brain is not just a passive organ processing reality as it is. It is an adaptive, predictive, self-regulating system designed to keep you alive in an uncertain universe. And only recently have scientists begun to understand a hidden feature within this system that changes how we interpret stress, limits, perception, and even consciousness itself. At its core, the brain is not a thinking machine. It is a survival engine. Every thought, emotion, every thought and sensation emerges from one fundamental task: predicting the world well enough to maintain internal balance. Neuroscience calls this balance homeostasis, but modern research suggests something deeper. The brain continuously builds internal models of reality, comparing incoming sensory signals with predictions it generates internally. When reality matches the model, things feel smooth, familiar, effortless. When it does not, the brain must adapt. This constant comparison happens below awareness, like background code running a complex system. For a long time, scientists believed the brain simply reacted to stimuli, but now we know it actively constructs experience. You do not see the world as it is. You see the world as your brain predicts it to be, updated by sensory data. This insight alone reshapes how we think about perception, stress, and mental limits. Neuroplasticity is often described as the brain's ability to change, to rewire itself with learning or injury. But recent discoveries suggest plasticity is only the visible surface of a deeper adaptive mechanism. Beneath conscious thought, the brain dynamically reallocates resources depending on perceived threat, uncertainty, and energy demand. When life feels overwhelming, when attention narrows or memory seems inaccessible, this is not damage. It is regulation. Think of the brain as a complex energy network rather than a static organ. Each neuron consumes energy, and the brain, despite being only about 2% of body weight, uses roughly 20% of the body's energy. This means efficiency is not optional. It is essential. Under stress, the brain shifts into an energy conservation mode. Regions associated with abstract thinking, long-term planning, and self-reflection may reduce activity, while systems responsible for rapid response, threat detection, and habit execution take priority. Subjectively, this can feel like losing intelligence, creativity, or emotional depth. Objectively, it is the brain doing exactly what it evolved to do. This is where the hidden feature begins to emerge. Scientists studying extreme environments, from deep-sea divers to astronauts, from trauma survivors to elite athletes, noticed a pattern. Under sustained stress or uncertainty, the brain activates a protective adaptive state that temporarily alters perception, time awareness, and cognitive bandwidth. This state is not pathology. It is a controlled shift in operating mode. In neuroscience, this is increasingly understood through the lens of predictive processing and allostatic regulation. Allostasis refers to achieving stability through change. Instead of keeping internal conditions fixed, the brain anticipates demands and adjusts in advance. Stress in this framework is not inherently harmful. It is a signal that triggers recalibration. When you feel mentally limited, overwhelmed, or emotionally blunted, the brain may be intentionally reducing complexity to preserve function. Consider perception. Under normal conditions, your brain integrates vast amounts of sensory data into a coherent experience. But in threatening or uncertain situations, perception becomes selective. Vision may narrow, hearing may dampen, time may feel distorted. This is often described as tunnel vision or dissociation, but research now shows it is an adaptive filtering mechanism. The brain reduces informational load to focus on what matters most for survival. What feels like disconnection is actually prioritization. This challenges a deep cultural assumption that optimal brain function means maximum awareness, maximum emotion, maximum cognition at all times. Biology disagrees. Optimal function is context-dependent. The hidden feature scientists are unlocking is the brain's capacity, to dynamically lower conscious access to certain processes in order to maintain system stability. This is not suppression in the psychological sense. It is modulation. Think of it like a power grid during a storm. Non-essential circuits shut down so critical systems stay online. The human brain does the same. Memory, retrieval, emotional nuance, even the sense of self can temporarily fade, not because they are broken, but because energy is being rerouted. This reframes how we understand limits. When you hit a mental wall, it may not be because you are incapable. It may be because your brain has determined that pushing further would risk system integrity. This is especially relevant in chronic stress. Long-term uncertainty keeps the brain in a semi-protective mode. Over time, people interpret this as burnout, loss of motivation, or personal failure. But neuroscience suggests something else. The brain is adapting to a perceived environment of constant threat or unpredictability. It is conserving resources, simplifying models, reducing exploration. In evolutionary terms, exploration is risky. When conditions are unstable, exploitation of known patterns is safer. The brain chooses safety over growth, not because growth is impossible, but because survival takes precedence. This is where the twist becomes clear. The moments you believe you are weakest may be moments when your brain is working hardest to protect you. The numbness after emotional overload, the mental blankness during extreme pressure, the sense of detachment in overwhelming situations are not signs of collapse. They are signs of a deeply intelligent system switching modes. Scientists studying trauma once viewed dissociation purely as a disorder. Now, many recognize it as a protective response. The brain limits conscious exposure to unbearable input. Similarly, stress-induced cognitive narrowing was once seen as impairment. Now it is understood as adaptive specialization. This does not mean chronic stress is harmless. Prolonged activation of protective modes comes with costs. But understanding the purpose of these states changes how we relate to them. Instead of fighting the brain, we can work with it. Another layer of this hidden feature involves prediction error. The brain constantly minimizes the difference between expected and actual input. When prediction errors are small, the system feels stable. When errors are large and frequent, stress increases. Under extreme uncertainty, the brain may reduce sensitivity to incoming data to lower prediction error. Subjectively, this feels like disengagement. Objectively, it is a rational strategy. By lowering the resolution of experience, the brain reduces surprise. This connects neuroscience with philosophy. Consciousness in this view is not a fixed spotlight but a flexible interface. What you experience is what the brain decides is necessary. This idea echoes ancient philosophical insights about perception being a construction rather than a mirror of reality. Modern neuroscience is now providing empirical support for this view. Even quantum metaphors become useful here, not as literal explanations, but as conceptual tools. Just as a quantum system exists in multiple potential states until measured, the brain maintains multiple possible interpretations of reality until action is required. Stress collapses this field of possibilities into a narrower state. Choice becomes limited not because freedom disappears, but because the system optimizes for survival. The human being, then, is not a static self, but an energy network constantly reconfiguring. Thoughts are signals, emotions are feedback. Identity is an emergent pattern. When scientists say they have unlocked a hidden feature of the brain, what they really mean is they are beginning to understand this dynamic regulation at a deeper level. It is not a new structure. It is a mode of operation. And it changes how we approach mental health, performance, learning, and even meaning. If weakness can be protection, then growth is not about forcing the brain beyond limits, but about creating conditions where limits naturally expand. Safety, predictability, and recovery allow the brain to return to exploratory modes. Neuroplasticity flourishes not under constant pressure, but under balanced challenge. This aligns with findings in learning science. Optimal learning occurs at the edge of comfort, not in chaos. When stress exceeds capacity, plasticity decreases. When safety returns, the brain reopens itself to change. Understanding this removes shame from struggle. It replaces self-judgment with curiosity. What if instead of asking why you cannot do more, You asked what your brain is protecting you from. This question alone shifts perspective. The hidden feature is not a superpower in the cinematic sense. It is something quieter, more profound. It is the brain's ability to modulate consciousness itself, to decide how much of reality you can handle, to slow you down when speed would break you, to narrow your world when the world becomes too large. Scientists are only beginning to map the neural networks involved in this regulation, including interactions between the prefrontal cortex, limbic system, and brainstem. But the implications are already clear. You are not broken when you feel limited. You are adaptive. And adaptation is intelligence in action. In a universe defined by uncertainty, the most powerful systems are not the strongest, but the most flexible. The human brain embodies this principle at every level. From synapses rewiring to perceptions shifting, from thoughts fading to emotions numbing, everything has a function. The challenge is not to override these processes, but to understand them. When you understand the system, you stop fighting the signal. You start listening. And perhaps the most philosophical insight of all is this. The brain's hidden feature reminds us that consciousness is not about control. It is about balance. Not about constant clarity, but about appropriate awareness. Sometimes not seeing everything is wisdom. Sometimes not feeling everything is protection. Sometimes slowing down is survival. The next time you feel mentally blocked or emotionally distant, consider this. It may not be a failure of your mind. It may be your brain quietly doing what it evolved to do, keeping the system intact while you navigate a complex world. And if science is right, learning to respect this hidden feature may be one of the most important steps toward resilience, creativity, and deeper self-understanding. If this perspective changed the way you see your own mind, take a moment to reflect and share your thoughts in the comments. If you value science-driven explanations that connect neuroscience, psychology, and philosophy, support MindSpark Science by liking this video and subscribing to the channel. Curiosity grows when we explore together.